Hello, ladies and gentlemen of Algebra 2. We are looking at 11.2 here, so we're going to talk a little bit about a geometric series. Sequence. Series comes later. So for a geometric sequence, what you're looking at is multiplication over and over and over again, or division over and over and over again. So what you're trying to do is figure out the common ratio. What is the thing that I'm multiplying by over and over and over again? And how can I use that to figure out a specific term in the sequence? So let's get back into it here. Sequences basically is a list of numbers in a particular order. So you're looking at an overall, what does my sequence of numbers look like, and how do I get from one to the other? So your arithmetic sequence we talked about before. That's where you're going to add or subtract by using a common difference. Geometric sequence, which is what we're focused on today, is going to be where you're multiplying by the same thing over and over again. And we say multiplying, but it could be multiplication or division. The way we represent that division would be by multiplying by a fraction. So that's how you would figure that out. So if I look over here, this is getting multiplied by 2, by 2, by 2, by 2. So my common ratio then would be 2. So here, Pascal's triangle, take a look at this. Just kind of be familiar with it. Be familiar with how to build it, because it does come into play every once in a while. So if I'm looking, find the next three terms of the geometric sequence, where I've got 3, 21, 47. And the easiest way to figure out your common ratio is just to take a term and divide it by the previous term. So if I take 21 over 3, I take 147 over 21. That's going to be 7. 147 over 21, I really hope is also 7, and it is. So my common ratio is going to be 7. So that's the fastest way to figure out your common ratio. Take 1 divided by the other. So I'm going to take 147 times 7. So that's going to give me 1,029 times 7 again is going to be 7203 times 7 again is going to be 50,421. That's my answers. So now figure out my common ratio for this one. So like I said before, take your second term divided by your first term. So 6 over 12, you've got 3 over 6, you've got 3 halves over 3. Each time, that's going to give me a common ratio of 1/2. So my common ratio, I'm multiplying by 1/2 over and over and over again. And this is also be how I represent, like dividing by 2, multiplying by 1/2 would be the exact same thing. All right, so in a geometric sequence, okay, to cut right through to one specific term, I'm going to take my first term times my common ratio raised to the n minus 1 power. Okay, so this is my explicit formula to find a specific term in a sequence. So a sub 1 is going to be the first term. All right. A sub n is going to be the nth term, which is oftentimes what you're looking for. R is going to be my common ratio, and n minus 1 is going to be 1 less than the term you're looking for. So figure out the 8th term of a geometric sequence where a sub 1 is 3 and r is negative 2. Sorry. So if I'm looking for the 8th term, my first term is negative 3. My common ratio is negative 2. I want to raise that to the 8 minus 1 power, so negative 3 times negative 2 to the 7th power. Then it's a matter of order of operations. So if I take negative 2 to the 7th power, and then multiply by a negative 3, I get 384. So that should be my answer. So write an equation for the nth term of the geometric sequence, 3, 12, 48, 192. So if I'm looking at this thing, 12 over 3, 48 over 12, all those are going to give me 4. So my common ratio is going to be 4. 3 is going to be my first term. All right, so what is that going to look like? So if I'm looking for my nth term, that's going to be 3 times 4 to the n minus 1. That would be my equation for that. So find a to the 9th, that means your 9th term. If the a to the 4th is 16 and r equals 4. So now for this one, there's a couple different things I can do. Okay, so a to the 4th is 16. You know, it'd really be nice if I had a to the 1st. Well, what I can do is I can kind of pretend that, you know, this is a sub 1. I can kind of pretend that that's a sub 1. Then if that's a sub 1, a to the 9th would be a sub 5. So if I think about this, so there's 1, 2, 3, 4. I know that this is 16. 1, so there's 4, 5, 6, 7, 8, 9. This is the term I'm looking for. Well, how many times do I multiply? 1, 2, 3, 4, 5. So if I treat this like a to the 5th, then that kind of becomes a to the 1st. So if a sub 1 is 16, 2, 3, 4, 5, I want to multiply times 4, but then I want to take it one more step. So this becomes a to the 1, 2, 3, 4, 5. Actually, if this is my first one, if I'm pretending this is my first one, then this kind of becomes my 6th term if I count that out. So I actually want to take 16 times 4 raised to the 6 minus 1. So I'm going to take 16 times 4 raised to the 5th. So 4 raised to the 5th times 16. This one should actually be 16,384. And if you kind of draw it out like this, I don't know, that helps me visualize it when I can see it like that. So I know that this is the 4th term they gave me. And I know they're looking for the 9th term. Well, if I kind of rewrite it, this is my first term, 2, 3, 4, 5. This becomes my 6th term. So 1 to 6, that's going to be 5 times. That will help me figure that out. So a family of mice have found a 50-pound sack of grain. 1/5 of its weight in grain is disappearing every week. How much of the grain will be left after 3 weeks? So you're starting off with a 50-pound sack of wheat. 1/5 would be 0.2 as a decimal, or 1/5, either way. How much will the grain, so 3 weeks go by, so you're going to take 0.2 raised to the 3rd times 50. So after 3 weeks, if they're eating 1/5 of it every week, after 3 weeks, there's only going to be 0.4 pounds left. Yeah, so all right, so get into the next one. Each year, Miss Meyer's teacher's retirement increases by 15%. If she has $27,000 in her retirement now, how much will she have in the account after 7 years? So you're looking for, so your initial starting amount would be $27,000, and each year you're going to increase it by 15%. So I would put 1.15. And I would do that because it's increasing by 15%. So you're going to take your initial amount and add 15% to it. So that's what the 1.15 is. So how much will she have in 7 years? Okay, so at the end of year 7, so almost at the beginning of year 8, how much money is she going to have? So I'm going to raise that to the 7th power. So this would be like A1. This would be my common ratio. And at the end of 7 years, it's almost like the beginning of year 8. So that's why I'm raising it to a power of 7. So when I do that, I get 71,820.50. That is my dollar amount. So recursive formula is means it's kind of working backwards. It kind of says you start off with one term, but you also know the rule, so then you've got to figure out more terms. So recursive formula says here's a rule, here's a term, figure out the next terms. So it's kind of the slow way of building it. So if it's the first term is 4, how do I figure out the next term? Well, that means the second term is going to be 3 times a to the 2 minus 1 minus 2. Well, that means that'd be 3 times a to the first minus 2. So that'd be 3 times 4 minus 2, which is going to give me 10. So my next number is going to be 10. So to figure out my third, term, I'm going to take 3 times a of 2 minus 1. I'm sorry, of 3 minus 1 minus 2. So that's going to be 3. 3 minus 1 would be a sub 2 minus 2, which would be 3 times 10 minus 2. So that's going to give me 28. And so on and so forth. So like my fourth one, a sub 4 will be 3 times 28, because I take the previous term, minus 2. So 3 times 28, 84 minus 2, so that's going to be 82. So then I got to do that one more time. So a sub 5 is going to be 3 times 82 minus 2. So that's going to be 244. So that's a recursive formula where you take one term and a rule and start building the other terms. So if I look here, this is another recursive situation. So I'm going to look for, so if I'm looking for the second term, that's going to be basically my first term plus n. So that's going to be negative 3 plus n. And then my n, in this case, is going to be negative 3 plus 2. So that's going to give me negative 1. So a sub 3, my third term, is going to be equal to my second term plus 3, because that's my n, that's what matches up there. So that's going to give me 2. A sub 4 would give me my third term, which is going to be 2. Okay, this is my a sub 3 plus 4, which will give me 6. So then a sub 5 is going to give me my fourth term plus 5. So that's going to give me 6 plus 5, which will be 11. There's my answer. All right, so you've got to be very diligent. Once again, be careful with order of operations and things like that. And then take your time, work through it, and come talk to me with questions.